All right, class, in this video, we are covering page 81 in your note packet on section 6.3, Riemann sums. And just to remind you what this section is about, we are estimating the area under a curve and above the x-axis for between two values of x on the x-axis using rectangles. And so we're going to be demonstrating that with some examples. So at the top of page 81, right, we have the definition of a Riemann sum, right? A Riemann sum is just the sum of all the rectangles, the area. A Riemann sum is just the sum of all the areas of the rectangles that we use to estimate the area under a curve and above the x-axis. And so using a summation formula, hopefully you're familiar with this from your high school math, right? We're going to sum n terms from I equals 1 to n, and the f, each term consists of a f of x sub I times delta x, and this is just the area of one of the rectangles. Delta x is the width of the rectangle, and the height of the rectangle is determined by the function value for some value of x for that ith rectangle. So I equal 1 to n, we're just adding up the area of n rectangles. So delta x, this right here is read delta x, and it means change in x. This is the formula that we use to find delta x. We'll be using it down below in our first example. I'll explain more about that. And then, as I said over here, x sub I is just some value of x for the ith rectangle. So let's demonstrate Riemann sum with this example down here, example 1. We're going to compute what is called the left endpoint Riemann sum for the function f of x is equal to 1/2 x squared plus 1. And we're going to use two equal subintervals over the interval from 0 to 2. Now remember, these are the values of x. So that means we're talking about values of x greater than or equal to 0 and less than or equal to 2. So here is the graph of the function f of x equals 1/2 x squared plus 1, and we're going to estimate the area under this curve from x equals 0 to x equals 2. That's what this means over here, right? From x equals 0 to x equals 2. So we're going to estimate this area under the curve, okay, and above the x-axis from x equals 0 to x equals 2. Using two equal subintervals, that means the number of rectangles n is equal to 2, and over the interval from 0 to 2 means the first number in interval A is equal to 0, the last number in interval B is equal to 2. So to calculate the width of each rectangle, right, we plug in delta x, the width of each rectangle is equal to b minus a over n. B is 2, a is 0, n is 2. And so we get the width of each rectangle, delta x, is equal to 1 unit. So then that helps us to determine where the base of each rectangle is. So since each rectangle has a base of 1 unit, right, starting at x equals 0, the base of the first rectangle goes from 0 to 1, and the base of the second rectangle goes from 1 to 2. Okay, that's what this means here. Subinterval 0 to 1 is the base of the first rectangle, and the subinterval from 1 to 2 is the base of the second rectangle. All right, and so now we got to pick a value of x in each of these intervals to calculate the height of the rectangle width. Well, we're told to do a left endpoint Riemann sum. That means you pick the left number in each of these intervals, subintervals, for your value of x. So the left number in the first subinterval from 0 to 1 is 0, and the left number in the second subinterval from 1 to 2 is 1. So these are the values of x that we plug into the function to calculate the height of each rectangle. So at x equals 0, what's the value of the function? Well, f of 0, put in 0 for x up here, and we get f of 0 is equal to 1. So the height of the first rectangle is 1 unit. In the second rectangle, x is equal to 1. So when we put in 1 in for x up here and do the arithmetic, we get f of 1 is equal to 1.5. So the height of the second rectangle over here is 1.5 units. And so you can see that I have drawn the first rectangle, goes from 0 to 1, has a height of 1 unit, and the second rectangle, which goes from x equals 1 to 2, has a height of 1.5 units. And then I've shaded in the rectangles. Okay? So the formula for adding up the areas of the rectangles, right? LRS stands for left end point Riemann sum, is equal to the height of the first rectangle times its width plus the height of the second rectangle times its width. And you notice that delta x is going to be a common factor in the Riemann sum. So you can always factor out the delta x, and then you just add up the function values, multiply that sum by delta x to get the total area of the rectangles. And so the height of the first rectangle is 1, the height of the second rectangle is 1.5, the width of each rectangle is 1 unit, and so 1 plus 1.5 is 2.5 times 1 is 2.5. So the total area of the rectangles up here is 2.5 square units. And we can see that this underestimates the total area under the curve from x equals 0 to x equals 2, because you can see there's a little bit of area here unaccounted for, and there's the area up right here that's unaccounted for. And so our estimate, our left end Riemann sum, right, in this case, underestimates the area under the curve and above the x-axis from x equals 0 to x equals 2.